So I'm the one between us and dinner, I guess. So I'll make it as quick and interesting as I can. You can tell I'm English. I'm Lee from a little company, German company called ZEISS, and I focus on aerospace. For those of most people in the room have probably touched ZEISS at some point, even if it's with glasses or medical sector, but we have a whole division that looks after industrial quality solutions. That's hardware, software, and services which cover everything from your manufacturing, testing, development, from coordinate measurement machines that you'll all have to some cool industrial microscopes. And the topic of the talk was to show you some of the novel. Now we have lots, and I've picked on two today. So these 7 different divisions, 7 different types of hardware, software, and service, they really support the industry right from concept and early development phases through to end-of-life manufacturing, repair, and overhaul, and everything in between. So production monitoring, production control, and first articles like we've just heard. So the 2 topics I'll bring are first the ZEISS Prismo. So this is, let's say, a classic CMM that you might have and seen or experienced in your own environments or in your suppliers. And this particular product is 25 years young, let's say, but something that we as a company, we always invest in back in new developments. And for 25 years, every 2 to 3 years, we've been investing and improving this to be really state-of-the-art. Some examples, a Prismo Ultra, a kind of half a micron accuracy machine, through to the Prismo Fortis, where it's had enhancements to work better on the shop floor, and thousands of these now existing in the field. And what makes the CMM special, or as I CMM special, it's the flexibility that matters in this case. And you can see a wide variety of tools there at your disposal to support all of your different application needs. We call it the multi-application sensor system, or MASS system. You can see things from surface finish to traditional tactile, interferometric sensors, lasers, and so on. And these are there, and they've been in place now for the last 10 or 15 years to really be versatile with your needs. The most recent introduction was in April of this year, where we launched the CMM acceleration mode. And I'll talk over this short video. Hopefully it's not too loud. But this shows the enhancements that have happened. So in this case, we've replaced the controller, we've upgraded that, as well as the software. And what this does is it really harmonizes all of the axes working really closely together. So if you've seen existing measurement rooms, even with some of our older equipment, it can be seen to be quite a slow process. This is more than 70% quicker than our last generations of sensors, and those familiar with Bliss there will see that we're measuring sections. It's all continuous and in constant contact with the aerofoil, measuring this one in around 40 seconds, which again, compared to history, is a real step change in performance. And I think there's still a lot of life in CMMs as a solution, and we are continually developing. So in terms of a novel, that's the number 1. And then the second one is the Atos technology. This is 3D scanning, digital twin creation, these sort of buzzwords that you're probably very much familiar with. And this is also 25 years in the making now. It's the 5th generation, and by that we mean that the data acquisition, the data quality, and the speed in which this is all done is really out there at the kind of cutting edge of 3D scanning. Resolution into single microns, and also a lot quicker than the previous generations. Rather than show you another blade and stuff like that, I would show you something that's somewhat larger. So the principle here, this is an operator interface, and it's inside of what we call a scan box. So as the name suggests, you can see there that the different positions the robots are moving these to, each one capturing in 3D 12 million points at each position, and building that back together in a digital twin. That's sometimes known as an STL or a mesh, but it's your actual representation of the real part. And you can see we've sped it up there, but this would only take maybe 10-15 minutes on a part this size. And the overall, this is around 6 meters in length. Those that think it is kind of novel, new, but at the same time, it still does a very traditional measurement. You can see an inspection plan, an inspection report there, whereby we're doing very traditional checks. So it's something that you can very much put into an existing process without really too disruptive, if you understand. But the advantage there of gathering this 3D, and again, where we become novel is in the software. So to highlight 2 features here which make us a little bit different. In this case, this is a part from the aircraft, where you can see after machining, it's kind of shaped like a Pringle. If you see the dark blue areas, this is where it's been deformed. And this is really normal for the manufacture of that part. But what you're able to do with 3D data, and in particular with our software, is to unwrap it. It's to really put it back without having to do that physically. And that saves money, that saves time, that saves costs in your process. So having that 3D data enables you to do things that are perhaps unthinkable. Another example, 3D throat area. Anyone that's familiar with design or manufacture of these things will know that the throat area is really critical in the design phase. And what we do is bring that world closer together, the design with the manufacture. And in here, just go back and show again, we are looking at the absolute minimum section between those 2 aerofoils, which determines the throat area. Today, that would only be done by an approximation, but we've included this and developed this alongside some of our customers to make sure that we really start to bring the worlds of design and manufacture together. So, tried to cram a lot into a short talk. You know, hundreds of years of innovations and a growing footprint. I often say that we're kind of one of the best kept secrets because we don't always put enough out there about what we can do to support your challenge. We're here also for the next 2 days, just in the booth, just as you enter, number 7. And we'd very much take any questions or speak to you over the next couple of days. Thank you.
Maybe we have 2 questions. Maybe you can answer them here on stage.
Yeah, sure.
That's
sure.
good. So the first question is, where can we see or test the Prisma machine?
Okay, so the new Prisma machine that I showed you, you'll see one of those in our headquarter, which is in Oberkochen, so kind of halfway between Stuttgart and Munich. So yeah, we've got one in Germany. Second one?
Second, up to what size of part can you scan with a 3D scanner?
Okay, the 3D scanning, that can go really quite large. I'd say comfortably, parts up to maybe 8 to 10 meters would be possible, and down to really small things. Beyond that, not impossible, but certainly I would say comfortably up to 8 to 10 meters.
Thank you very much again.